on. Come on, computer, you can do it. There we go. Alrighty, so I'm hoping that since I was doing all this from home, I don't know if it's because I'm at my desk at home or what. Sometimes my stuff doesn't animate the right way. Let's see. I'm not even sure who's still remote and who's not, but I'm pretty sure that one's remote. 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 Okay, Kill is back. Yours must have lasted just as long as mine did. Yeah, I just published the thing for the opener. So I just heard a ding. Hold on just a second here. Let's see what we got. You're not quarantined, you're just doing online. Okay, well, I got you. Okay, we are going to get everything back up to the right thing. We started this Monday of last week, and I decided it would be better just to sort of pause and then come back and finish this. So the geological notes that we did a week ago, the one that had sort of the curly Q looking timescale on the canvas, those are going to be checked for this 6 weeks notes. The assignment was on last 6 weeks, but the notes are on this 6 weeks. And we're just going to pick back up. So we're going to sort of refresh a little bit, and we're going to specifically go into relative dating, the 4 major ones today, and then we're going to go into some of the fossil type things, index fossils tomorrow, and then we're going to get into absolute dating. We will actually go over half-life. I'm not going to make you guys do the logarithm, but if you know that the amount of time for a half-life, you know how much of the material is left over, it's very, very simple to figure out how many half-lives occur, and multiply that by the half-life, and that's how much time has passed. But that'll be Thursday. I need probably to build an extra set of notes for Friday and do what I have for Friday, move to Monday, which looks like our next test will be Wednesday of next week, I think. I just didn't go quite that far. For this opener, for this focus, if there's no major like asteroid strikes or like volcanic eruptions, like there's no like chaos occurring, how does sediment form specifically in a body of water? Like how does it lay down? If you go underneath a pond or the ocean, you take a cross section of sediment, what will you see? No idea, you're not going to.
It's flat.
Well, it will be flat, but if you literally cut it like a cake, what will you see with sediment?
Layers.
Okay, so what will the layers tell you? Exactly. So which are the old ones and which are the new ones?
The new ones are on top of the old ones.
That's exactly correct. So in superposition, which is the first one that we're going to talk about, and also into horizontality, your older stuff is you're going to have stuff sink down and it's going to form a layer. It's going to lithify. It's going to turn into rock. You're going to have other stuff, dead animals, whatever, dead plants, some type of debris, that's all going to break down, settle down. That's going to make the next layer, just like cutting a cake. And your youngest stuff will be on the top and your oldest stuff will be on the bottom. Now, there are things that happen where that's not always a true statement, but if that's perfect and there's no volcanic eruptions, there's no angular motion, there's no earthquakes, there's nothing like that, then you have these perfectly flat layers where at the top will be your youngest and at the bottom will be your oldest. I did print out paper notes. Is there anybody that really prefers paper notes? You know, we switched over to everything online because we had to. What is this? Where is my cursor? Uh-oh, am I out of batteries? On. Oh, maybe not. Okay, let's turn it off. So we are going to be talking about relative dating principles. We're going to talk about this for a couple days, just because there's way too much to fit into one lesson. There's no way. there was an individual that 3 of the 4 ones we're going to talk about, he was the one that came up with this concept. And so he came up with superposition, he came up with horizontality, and he also came up with the other lateral continuity. And we mentioned these a week ago. I know you don't remember them, so they're all built into this anyways. But if it's perfect, if there's no major catastrophes going on, you get these perfectly flat layers that develop, and they stack on top of each other like pancakes or like layers of a cake. And we use this a lot to determine what is called relative age. And there's no year set to this. That has to do with technology much later on. This is way before we understood, like 200 years kind of before we understood radioisotopes. All this tells you is this section is older than this section. And the deeper you go, the older it is. That's really what superposition says. So there's no, so I can go along with this with you. Yeah, I put a whole bunch of images in your canvas for this. In fact, I did it all throughout this stuff because there's so many things that if I didn't give you the actual image, you'd be writing forever. See your pictures. You guys have this in Canvas. The law of superposition just basically says, and this is just to give it to you, just says that the further down you dig, and I know you guys online can't see it, but if I move my cursor, the further down you dig, each layer of sediment or rock is called a strata, S-T-R-A-T-A. So if you see that, that just means a specific layer that can be told apart from other layers. And as you go down, you are essentially digging further back in time. Now, we will tomorrow start talking about index fossils. And the ammonites, these are really, 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 really common. And then you've got your brachiopods. I gotta remember all my scientific terms. I can't remember that one off the top of my head. But there are certain index fossils that were very, very prevalent in certain geological times. And the oldest of them all are the trilobites. I don't know if you've ever been to like a history museum. They almost look like a, they look similar to a silverfish, you know, the things that you find with like books and in cardboard boxes, but they were much more round. In fact, the general body style of a silverfish is one of the oldest ones that are still around. But those were sea creatures. But we'll talk more about index fossils tomorrow. Original horizontality, same guy, same exact guy. And this just says that your sediment is in a nice, perfectly flat, horizontal is this way, vertical is up and down, horizontal horizon, side to side. And it'll sort of taper out to the ends, and especially if you've got like a sea floor that's coming up, or maybe there's a mountain on the other side. But it just means that it lays stuff down in a nice flat layer. And yes, this is best in an ocean type environment, but it does it everywhere. On land, it takes about 100 years to make an inch of dirt, give or take. In the ocean, it's a little bit different. You've got natural erosion, you've got motion of waves. But in general, Earth's gravity is going to pull things down, and it's going to make this nice, flat, pancake layer. Superposition and horizontality go hand in hand. Now, if you've ever been whitewater rafting, or maybe you're driving down the road, I see this a lot through, when you're going up through Oklahoma, northern Texas, where you get ready to cross the river, where the road goes through, you can see where they blasted the rocks on both sides and the road goes through. But you can see the different layers and they're not always perfectly flat. Sometimes they're on tilt. That normally happens after we have what is called lithification. This just means turn to stone is what lithification means. Whether it be earthquake related, which isn't as common here, but it can happen. To my knowledge, in our area, we haven't had any major large meteorite strikes. I know Arizona's had a few. Russia's had a whole bunch. But if it doesn't look perfectly flat and it's on an angle, something happened after all that sediment deposited and was turned to stone. Otherwise, if it happened when it was still soft, it would flatten back out. And then I have a few pictures.
Question.
Yes.
Is it supposed to still be locked?
Shouldn't be.
This is the only that actually, I won't be in the lock.
Hold on, let me double check it, make sure I didn't put a wrong date on it, which is quite possible. Let me double check. You talking about the assignment? Okay. Okay, that's because I did not change the date from before when I did this. So it's going to be due what day is it today? The 2nd? It's due the 3rd, and it's from the 2nd. It's because we originally were going to do this last week, so it still had the old dates on it. Refresh it, it should be open now. Make sure I didn't do that to something else. I thought I fixed all of that yesterday. 2nd to 4th, the opener's fine. The assignment's fine. Check this. It should work for you now. And I should have given you 2 attempts too. Let me double check. Yes. Allowed attempts too. Okay, everything else looks fine. It should work for you now. I apologize. I'm going to blame it on being stuck at home for a week and a half and trying to teach with an 8-year-old constantly bugging me. I don't know how many times she came in when I was talking to y'all in first period. Can't tell you how many times she ended up crying because I snapped at her because she was bugging me too much. I felt bad. And my stupid cat kept stomping on my keyboard. All right, so this is an example of if you're driving. Like I said, when you drive through the rocks that have been blasted, you can actually see where they drill the bores down to be able to put the dynamite. You can see them. It's very, very, very clear if you've driven through one of these where they literally drill the hole down to the bottom and they put the TNT down there to be able to blast the rock out so that you can drive through it. You don't have to drive around it. But normally, as long as there's not, I think there's one more, okay. As long as there's not something major that's happened, you see these nice flat layers that are different colored. And I know those of you that are online can't see my hand up here on the board, but in the picture that's off to the right, on the very bottom, you have this sort of a darker tan, and then above that you have a lighter tan. It has a really nice dark line in the middle of it. Above that's another darker one. Each one of these were deposited at different times, and dependent on what's present when the sediment is laid down is going to help determine its color. It might be determined by, well, normally it's the plant matter that's there. If you dig down far enough, you can find something called the K2 boundary, which underneath that you find the majority of your dinosaur bones, and above that you just don't. And that K2 boundary is a really nice black band. It's extremely obvious that it's not normal. And it's filled with iridium, which is commonly found on asteroids. And was one of the first things that led us to, okay, that's what caused the beginning of this mass extinction. Let alone that we were actually drilling down into that asteroid that slammed, excuse me, off the Yucatan Peninsula 65 million years ago. I know they're still doing research on it. So in a marine environment, you're going to have the most perfect of your flat lines. It happens on land too. It's just, we have erosion a lot on land, and you don't necessarily at the bottom of the ocean. We'll get into erosion and the way that we'll start plate tectonics probably at the end of next week. There's no way we're going to finish it. We're not going to get into Rodinia and Gondwana land and all that until later. It's the like Pangea, everything broke apart, started coming back together. We'll start doing that this 6 weeks, but we're not supposed to get into depth with that until the fourth 6 weeks, or so says my little map thing that I'm supposed to follow. But in general, like I said, superposition and horizontality go together. The further down you go, the older it is. The further towards the surface, the younger it is. And like I said, there are some things that happen that change that. Anybody still need this one? Yeah. Okay. Lateral continuity. Same dude. I've never been to the Grand Canyon. I mean, I've been to areas where I've seen decent cut throughs with rivers. But if you look on both sides, they're not necessarily the same height. Normally they're pretty close, but you can see the different color bands and they match from one side to the other. That's lateral continuity. They're not always perfect, but it's almost like matching up pieces of a puzzle. I think that's the only one that's on this one. Now, a deposition or a deposit just means that something is laid down. A basin is just the floor of wherever it's being put. I'm not trying to put the notes up too textbooky. Well, we don't even have a textbook for this class. But your sediment, whatever it is going to want to lay down flat in all directions. And if you have a river that cuts through, that stuff will be eroded where the river cuts through, but you're still going to see the same thing on both sides. When we're talking about very, very, very long distances between each other, this doesn't work. That's when we use index fossils. We'll get into those more tomorrow. You can't put everything together in one class, or you won't have any time to do the assignment. Let's see, so colors right here. Let's see what is here. You know what? Let me double check on that real quick. You guys are doing this. See if anybody else did it. It's odd. At home, my computer dings like crazy, and here it doesn't. Okay, I do see Natalie. Sarah, I got. Joseph, I got. Decker, I got. Chase, I got. Did I get Braylon? Yes. Okay. I have no idea what that is. Oh, it's frozen. That's why. You should have this in Canvas too. This is an example of what I was talking about. So the top image A up at the top, this is your superposition and your horizontality. Everything has got nice even layers. So this is going to be your older material. The white's going to be the next one up. Then we have this red layer. We've got whatever this yellowish layer is. We got water on top. Well, then something happens, and then you have a change in the motion of your water, and it's going to cut a channel, and which is what this lower image is actually showing you. And if you look from left to right, you can see that the colors match. So you've got this nice red clay layer. Above that is a darker band. Above that is the lighter band. So you can see that they actually line up with each other. And sometimes they look perfect like this. And this almost looks like this is the Snake River. I'm not 100% sure which image this was that I blatantly stole off the internet. But it does show how they match up from side to side. And I should have put this in your Canvas. Cross-cutting. Cross-cutting is a little different. You have some type of geological event that occurs. This is a different dude, Hutton. Igneous means volcanic. Okay, so you have some type of a shunt. And you've got like an upflow of magma. whether it actually punches through the surface or not as a volcano, you have material that is being pushed up in a column. And there's different phrases that we can use for this. Dike does not mean a bad thing. Okay, so a fault, a dike, or a fissure, and they're always going to be darker in color than the rock that they're actually pushing up through. And I remember seeing these as a kid and wondering, why did that do that? And it wasn't until I went through and researched it, I said, oh, well, that makes sense. So we had some type of volcanic activity that was occurring. With all that pressure, it wants to, just like popping the top off a bottle, it wants to shoot up through the rock. Sometimes it does make it through, sometimes it doesn't. And I will show you images. If it's not today, it'll be tomorrow. No, there is one with the geological principles that I'm going to show you as a recap. But tomorrow, I will show you different, like if you look at this particular image, this is black and white, which is the oldest and which is the newest. If you have a fault, that pushes up, okay, I'm hearing things now. It's going to be younger than anything that it cuts through. But if it hits a barrier and it stops, then the barrier that's above it is actually older than that particular shunt. And we'll go through this tomorrow more in depth if I'm remembering right. So you have, like I said, you have an upflow of magma. It's not lava until it breaks through the surface. And it literally melts the rock as it's going through it. It changes its particular chemical consistency, and when it cools, it is almost always, if not always, darker than the material that it went through. But your line, it literally looks like a dark line that comes up through the rock, is always younger than the rock that it cuts through. Always younger. We've got one more. I'm going to take a look at recapping these as images, and you should have more than enough time to do this. I was trying to make these a little bit shorter so I had enough time to do my own maintenance since I'm now back after almost 2 weeks. But yeah, don't let the words mess you up. Igneous just means it's volcanic in nature. Intrusion means it's being forced through, it's younger. And yes, we can call them shunts, we can call them fissures, we can call them dikes, we can call them, what are the other phrases? Faults. Not like earthquake fault, that's different. That's different. Back. And so this is an image of what I was talking about, and you can very clearly see where this red line is pointing to, that this is not the same as the rock that's around it. And it doesn't really have a lot of different layers. This looks, I think it's granite. I'm not sure what the actual rock is, but I can get my, there you go. Oh, it says it is granite. So this is all the same material. I'm jumping over that line. Something occurred, and we had this fault or dike or shunt or whatever you want to call it that was pushing through, trying to come up to the surface. This is younger than the granite that it is cutting through. Any intrusion, any fault, whatever you want to call this thing, they are always younger than the rock that they come through, and they are almost always darker in color. And I've learned that Canvas does not like pictures. So we will see the next test that I have if I even try to put images on there, because we learned with, not that edgeophorial one, but the test that you had before the 6 weeks exam, that it didn't like one of those air mask pictures, and there's nothing wrong with an air mask picture. I don't understand if maybe it's where I'm pulling the image from that Canvas has an issue. It liked all the other ones. I don't know. And I could see it on my side, so I don't know. I'm learning Canvas still. All right, so this one, there's a very, very, very small fault. Now you can see that you have a shifting of the rock. And I know for those of you that are online, it's difficult to see, but we've got how they're moved, like they don't line up right. So you've got one that matches here, you've got one that matches here, you've got this guy matches here, this one matches up here, and then you have natural erosion that occurs too. Now we're not talking about erosion and all that quite yet. We're not getting in there. But this line, which does not go all the way completely to the top, but this line, this is your fault or your shunt or your fissure or your dike or whatever it is that the person decides to call it. But this is younger than anything that it cuts through. And like I said, they're not always perfectly flat. Something occurred here. I don't know if it was earthquake in nature, something occurred where you can see how they're trying to match up. That these are wanting to match and these are wanting to match. But something occurred in the past life of this particular section to cause those to shift. And we'll get into earthquakes and volcanic activity later on. We're not there at all. Okay, uniformitarianism. Also James Hutton, who's the father of modern geology. I can't remember if there's one more on here or not. There's not. Okay. This one is remote. So do you want me to help her? It's not online right now. It's just an email her. Okay. Okay, no other? Not yet. Okay. All right, thank you. Uniformitarianism just means that the events that have happened in the past are very, very similar to the events that are happening now. Now, they're not as commonplace now as they were towards the beginning of the Earth. The beginning of Earth's life was way more chaotic than it is now. Especially before we had global chemical differential, when we had that nice separation of the crust and then the core. But this concept, which to us is sort of like, well, duh, of course the stuff that happened in the past is similar to the stuff that's happening now, was sort of a new concept back in before the 1800s. And we didn't have electricity, we didn't have any of the technology that we have now back then. There should be one more. No, there's two more. Hutton was the one that says that the Earth is not necessarily alive like us, but it has these cyclical patterns, and we know that. It goes through warming and cooling trends. We're actually in a cooler trend as opposed to the era before us. So we're in the Cenozoic, which is a cooler time period. Before that, everything was like the equator, the entire planet around. It was a much warmer time frame. And we do have periods of a little bit warmer and a little bit cooler. Compared to about 400 years ago, we're warmer than we were back then. We had a mini ice age that went through the middle of the 1800s. And yes, we're warming up right now. I'm not getting into the whole global warming thing yet, okay, but a lot of the speculation is that the fact that with all of our technology and the burning of fossil fuels and whatnot has helped to increase the temperature. Okay, well, that might be true, okay, but it still comes and goes in waves. It's happened. I mean, it happened back with the dinosaurs. The dinosaurs were not burning fires. Like, they weren't riding around in cars. It warmed up and it cooled off, and it's a normal pattern, a cyclical pattern that happens on this planet. There's one more on this one. Yes, there is. So we've had variations. And we have scientists that go and dig those ice cores up in Antarctica, and the different layers tell different things. Now, obviously, Antarctica is a giant frozen mass right now, but it wasn't always that way. And they dig these core samples in order to study to figure out what has happened in the past. Let's just hope they don't dig up some really nasty, like mummy bacteria or something that like wipes out all life on the planet, because that would be horrible. But this concept, like I said, for us is like, well, duh, you know, that's, of course, that's the way it works. It was sort of a revolution back then. And then I've got one more image, which should be 100% in your canvas. And I don't think you guys can maximize the images that I give you. I'm not sure if you can or not. I put these together so it's normally one sheet of paper front and back. Just for my students that like the paper notes, it keeps them from having multiple pages. And I've had students ask, well, when's the next ice age? And when's this? And when's that? We don't know. We just know that we're overdue. We know we're overdue for an ice age. We know we're overdue for the Yellowstone caldera to go boom.
Now, what about Texas?
Okay, now I need to, when we get into volcanoes, I will pull up the map. Like there is literally a map that shows like the immediate kill zone. Okay, and then it shows like you're gonna get killed by the dust. Now, you're not just like blown to smithereens, like you're gonna be suffocated. You're gonna breathe it in and it's gonna turn into concrete inside your lungs. You're gonna die from that. Oh yeah, it's not pretty. We are not within the immediate death zone, but when the Yellowstone caldera does go boom, it's gonna put so much ash up into the stratosphere, it's gonna be a global wide nuclear winter. Because if it's up in the stratosphere, it's not like it can be rained out. And so if it's just like in the thermosphere, the rain will naturally wash that out. There's no rain up there. There's no, like, it has to eventually dissipate by itself. So it would, who knows how long? Years and years and years. And then people go, well, can we live underground? Possibly. The problem is you don't have sunlight. Like, well, we can just make artificial light. Okay, well, where are you going to keep getting the energy for that? It's not like you can use solar power. Well, possibly. So, I mean, I'm not saying like we're all going to die. I mean, we are all going to die. But like that is not going to be fun to have to deal with. I hope it does not happen in my lifetime. So, yeah.
Well, at least I'm not dying instantly.
No, you wouldn't be dying instantly, but it would be,
Well.
Okay, so this just sort of puts all four of them together. Superposition just means that your youngest is on the top and your oldest is on the bottom. Okay, and it's the same thing that's with original horizontality, but sometimes we have uplifting. Sometimes you have a depression. Sometimes it's opposite this. It looks like a bowl. But still, your oldest is at the bottom and then your youngest is at the top. Now, if we had erosion and we had a cut through like this, okay, that would look a little bit different. Like I said, we're not getting into erosion quite yet. Lateral continuity, you could see, like let's say that the river is right here at the bottom of this V, that you would see that these top layers match up, which would be the youngest. Cross-cutting. So your youngest would be the top layer. Next is going to be this fault, number 4. Then you're going to go older as you go down. Like I said, if it cuts through, it's younger than anything it cuts through, but not the thing that it stops underneath. So the youngest would still be the top layer in this particular image right here. Okay, now, let me turn on light first. We have 12 minutes for you to be able to do the assignments. Let me stop this first. Stop recording.